we are going to take our lessons direct from our living room at home, and we are here to help each other. We see that we can go through. So because the term must continue and the work must go ahead, and we see how we catch up with the syllabus, we say that let us remind ourselves today in class. We are with primary 7 members under the topic called machines, and mostly in this case we are dealing with the simple machines, and the area which we are going to talk about in the simple machines, we are talking about levers. We covered up levers and we discussed about levers, but we should remind ourselves, or we should know what levers are. But when they pose a question to you, what is a lever simply means is a stiff rod that turns on a fixed point called a fulcrum. When they ask a question, what is a lever is a stiff rod that turns on a fixed point called a fulcrum, as we see it here. So when we were talking about levers, I said that a lever is a stiff rod that turns on a fixed point called a fulcrum. As I've written it here, that a lever is a stiff rod that turns on a fixed point called a fulcrum. And when they ask us what is a fulcrum is a turning point of a machine. Where the machine turns from is what we call a fulcrum. So a fulcrum is a turning point of a machine, and we have what we call the classes of levers. Levers are grouped into 3 classes, and it depends on the classes. They depend on the position of the load, the effort, and the fulcrum. Because a lever has got 3 parts: the load, the effort, and the fulcrum. And there now we say that the levers are grouped into 3 classes. We have the first class lever, we have the second class lever, and we have the third class lever.
A lever is a simple machine, and they're a basis of many tools in and around your house and work. The way levers work is that a force is applied at a point, and this moves the load at another point through a balance point called the fulcrum. It's the position of these 3 points, the force, the load, and the fulcrum, that distinguishes the type or class of lever. There are 3 classes of levers: first, second, and third class. With a first class lever, the fulcrum is in the middle, and the force is on one side, and the load is on the opposite side, much like this seesaw. Other examples include scissors. Here's the force, here's the fulcrum, and the load. And also pliers. Second class levers have the load between the force and the fulcrum. For example, with this wheelbarrow, here's the fulcrum, here's the force, and then here's the load. A nutcracker is an example, and also a stapler. A third class lever has the fulcrum on one end, the force in the middle, and the load at the end. For example, with this hockey stick. This rake is a third class lever, and also a hammer. So there we go, 3 types of levers.
When you look at the machines in the first class lever, those machines, the pivot or the fulcrum is found in between the load and the effort. The machines in the first class lever, you see, we have the pivot in the middle, we have the load, and we have the effort. These are the machines in the first class lever. We group them when the pivot, the turning point, is in the middle. Then when you come in the second class levers, the second class lever machines, we determine them by seeing when the load is in between the pivot and the effort. So the second class lever, you find the load is in between the pivot and the effort. Those machines are in the second class levers. And the machines in the third class levers, we determine them by saying the effort. When the effort is in between the load and the pivot, those machines, we call them the third class levers. The effort is in between the load and the pivot. These machines are the third class levers. But today, we want to look at the calculations, some simple mathematics in science. How do we determine this distance? They can give you a number like this, but we are in science. And the number is a boy weighing 60 kilogram force. This is the question. They say a boy weighing 60 kilogram force. That is the weight of the boy. A boy weighing 60 kilogram force. 62 meters. A boy weighing 60 kilogram force, 62 meters. A boy weighing 60 kilogram force, 62 meters away from the fulcrum. 2 meters away from the fulcrum. 2 meters away from the fulcrum of the seesaw. From the fulcrum of the seesaw. From the fulcrum of the seesaw. And a girl, that's a boy, full stop. Then they say a girl, we say a girl sits on the other side. 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 A girl sits on the other side at a distance. Another at a distance of 3 meters. At a distance of 3 meters from the fulcrum. 3 meters from the fulcrum. 3 meters from the fulcrum. In order to balance the seesaw. In order to balance the seesaw. In order to balance the seesaw, find the weight of the girl. 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 So the question is, a boy weighs 60 kilograms, force 62 meters away from the fulcrum of the seesaw, and a girl sits on the other side at a distance of 3 meters from the fulcrum. In order to balance the seesaw, find the weight of the girl. Here are the 5 things we are going to do. We are going to draw the seesaw. After drawing the seesaw, then we look at how it's going to balance. You are going to calculate, but how do we interpret? We need to first interpret the question. When we interpret the question, we draw the diagram. After drawing the diagram, we are going to get the base out of our calculation. But if you cannot describe the diagram, if you can't interpret the words which are here, you cannot calculate. Let us first look at this one. By cleaning the side, then we calculate. First, what are we going to draw? They are talking about the seesaw, and they are telling us a seesaw is a stiff rod. This is the rod. A seesaw is a stiff rod that turns on the fixed point which we call the fulcrum. So let us say this is our boy. This is our boy on this side. Then you come to this side. This is our girl. This is the boy and this is the girl. Now this one is what we call a seesaw. the stiff rod that turns on the fixed point called the fulcrum. This from here up to here, this is the stiff rod, and this part here, simply this is the pivot, which we call the turning point here. Now, our interest is not to look at the position, but is interpret the saying, a boy weighing 60 kilogram force. The 60 is now here 60 kilogram force. This is for the boy. 62 meters away from the fulcrum. He's going to sit 2 meters away from the fulcrum, meaning from here up this point, which I call the fulcrum, here the fulcrum or the pivot. This point is 2 meters from where the boy is seated. Now, and they tell us that a girl sits on the other side at a distance of 3 meters. This is the girl. From where the girl is to the turning point is 3 meters. From where the girl is to the turning point is 3 meters. We are interpreting at a distance of 3 meters from the fulcrum, 3 meters from the turning point, which we call the fulcrum. In order to balance the seesaw, find the weight of the girl. Now, the weight of the girl is here. We don't know in kilogram. Now let it be X. We give it letter X. Now X kilogram force. We want to find the value of X. Here we shall come and say, I've interpreted everything. 60 kilogram force sitting 2 meters away from the fulcrum. This one is, the girl is 3 meters, but we don't know the weight of the girl. That's what we want to do. But what do? We come, in mathematics they teach us to be systematic by writing the word solution. We want looking for the working to interpret the thing. Now, let the boy become the load. Let the boy become the load, and let the girl be the effort. Let the boy be the load and the girl be the effort. When you want to balance the seesaw, we are going to say the load. This load here, load. This one, when you look the distance from the boy to the fulcrum, which is called 2 meters, that is the loading arm. Because this is the load, we call this distance the loading arm. And because this is the effort from the girl to the fulcrum, that one becomes the effort arm. But you want to see the weight of the girl. So we come and say solution, let the weight of the girl, be X. Weight of the girl be X. Then we are going to work out. To get X, we shall say load times load arm is equal to effort multiplied by the effort arm. In short, we shall say L times LA is equivalent to E times EA. This is load arm, this is effort arm. So we are going to say, here I've told you when you're working out, we don't know the weight of the girl, we say, let the weight of the girl be X. Then we come here and we say, the load times the load arm is equal to the effort times the effort arm. What is our load? Our load is 60 kilogram times the loading arm, which is 2 meters, will equal to X kilograms, which we don't know as our effort, being equal to the multiplied by 3 meters. So we are going to say load, which is 60 kilograms times 2 meters is equal to X kilograms times 3 meters. But this time when you reach on this stage here, when you're looking at this part, now we don't need the units at the first place. The units will come later after as the useless as you are going. Let us now pick only the numbers or the digits here. We shall say 60 times 2 is equal to x times 3. This one is going to give us 120 being equal to 3x. Let us make x the subject of the formula. We are making x the subject of the formula. How? By dividing both sides by 3. By 3 1, by 3 1, by 3 1, by 3 4. So this one 4. 12 divided by 3 you get 4 plus 0, that is now 40. Then we say from here that 40 is equal to x, meaning now the weight of the gun is 40, but 40 what? Then we come and say therefore our x is equal to 40 kilogram force. So the weight of the gun from the seesaw, from the fulcrum of the seesaw is 40 kilogram force. The weight of the gun from the seesaw is 40 kilogram force. Here we have worked out. I repeat and say by telling you that we started by saying we don't know the weight of the gun. We said the weight, let it be x, and we can calculate it. Here the load times the load arm is equal to the effort times the effort arm. Our load is 60 times the 2 meters is equal to the x times the 3 meters. We leave the units first apart. We come and calculate 60 times 2 is equal to x times 3. 60 multiplied by 2, you get 120, which is equal to 3x. But you want to get the value of x. We divide both sides by 3, both sides given this side by 3. 3 goes into 3 ones. Now 12 divided by 3 is 4. We add 0, becomes 40. So 40 is equal to x. But what are we looking for is the value of x. Then we said therefore with 3 dots, x is equal to 40 kilogram force. That is the weight of the gun. That is the weight of the gun. Another example, this is just very simple. Example 2, then after this example you will do the work on your own. Just very simple. This one I think you're following me. Then we go to example 2, just it is a diagram. Another example 2 is just a simple diagram. Example 2, they can give you, just I can get it from that one. They draw. This is example 2. Example 2 comes, they can say find the value of 1. Find the value of 1. And on the diagram, here this is the diagram. They draw the diagram in this kind like this. After drawing the diagram, they put for us this turning point. This side here, they write it very well again by telling us that this is 40 kilogram force, and this side they bring it and they tell us this is the 60 kilogram force. Then from here up to here is where they put the 1. Then from here up to here, they put here 3 meters. They have told us to find the value of 1. This one still is very simple. Just get one side and you give it. Let us call this side the load. Then call this side the load arm. We call this is the effort. This one becomes the effort arm. Come for calculation because we have asked us here. You write a word solution. After writing the word solution, we are going to use the same criteria. The one we use this side is the one we are using this side. We are going to say load. We are going to say load times load arm is equal to effort times effort arm. What is our load? Our load is 40 kilogram times the loading arm, which is 3 meters, is equal to this one, which is 60 kilogram. That is the effort, times our effort arm is already given to us as 1, is what we are looking for. We come here, first leave the units behind. We first deal with the digits. Come and say, this one, this is 40, and this is 60. Still, if you don't want to leave the digits behind, we can cancel them out. You cancel kilogram with the kilogram. But let us come here and say 40 times 3 is equal to 60 times 1. These units will disorganize you. Come here, 40 times 3 is giving us 120, which is equal to 61. What is our purpose in this? We are looking for the value of y. On the side of y is where we are making y the subject of the formula. Divide by 60, divide by 60. 0 goes into 0 0 times. By 6, 1. 6 goes into 6, 1. 0 goes by 0. When you divide by 0, you get a 0. 6 divided by 6, you get 1. 12 divided by 6, you get 2. So we are remaining with 2, which is equal to 1. Now therefore, y is equal to 2. Come here. Was y a distance or the weight? When you look on our on this bar, the stiff rod, y was on the area of the distance, and where the distance sheet is in the meters, because y is the effort arm. So y is equal to 2 meters. That is our work. This is how we calculate the unknowns. Because of that and having all that, I wish you do the activity which you are going to find out. Try to calculate the numbers on your own as you are enjoying our living room. I wish you the best. Then we meet the next time.